Typhoons were discussed in our previous video lesson. How they develop and how they are influenced by land masses and bodies of water. In this video, we'll go through the Philippine Area of Responsibility or PAR and how to use a map and track data to follow typhoons. The Philippine Area of Responsibility is the smallest and innermost monitoring domain, whose boundary is closest to the Philippine Islands. The exact dimensions of this domain are the area of the western North Pacific bounded by imaginary lines connecting the coordinates. First, at 5 degrees north and 115 degrees east, 15 degrees north and 115 degrees east, 21 degrees north and 120 degrees east, 25 degrees north and 120 degrees east, 25 degrees north and 135 degrees east, and lastly 5 degrees north and 135 degrees east. So, what do these figures imply? We have here a map of the Philippines. We need to know what these numbers signify in order to understand them. Learn the meanings of latitude and longitude. Latitude refers to the geographic coordinates that determine the distance of a point north to south of the equator. On the other hand, longitude refers to the geographic coordinates that determine the distance of a point east to west of the prime meridian. Now that we understand what these mean, we're ready to plot these coordinates. If we plot the identified coordinates on the map, we will be able to determine the Philippine Area of Responsibility. Let's get started plotting the coordinates. First, we have 5 degrees north and 115 degrees east, which is right here. Next, we have 15 degrees north and still 115 degrees east here. 21 degrees north and 120 degrees east. And 25 degrees north and 120 degrees east. Right here, moving further north, we have 25 degrees and further east, we have 135 degrees which coincide here. And lastly, 5 degrees north and still 135 degrees east here. Now that we have plotted the coordinates, let's connect these together. Connect point A to point B. Point B to point C. Point C to point D. Point D to point E. Point E to point F. And lastly, from point F to point A. The region within the plotted points is called the Philippine Area of Responsibility. It is the job of the Philippine Atmospheric Geophysical and Astronomical Services Administration or PAGASA to monitor all tropical cyclones that enter this area. So let's try this example. If a typhoon is located at 15 degrees north and 139 degrees east, is it within the Philippine Area of Responsibility? 15 degrees north is right here, however, 139 degrees east is not even within the Philippine Area of Responsibility. Thus, this typhoon hasn't entered or is not within the Philippine Area of Responsibility yet. Now, how about if the typhoon is at 19 degrees north and 117 degrees east, is it within the PAR? 19 degrees north is here, and 117 degrees east is here. When we intersect these points, we can see that it is still outside the Philippine Area of Responsibility. Let's try tracking a sample typhoon. Inside the table are sample tracking data. Let's plot these coordinates to know the direction of the typhoon. Using the latitude and longitude in the table, we are able to track the location of the typhoon at a given time. In knowing this, we will be able to forecast if our location is in the path of the typhoon. Using the data in Table 1, plot the day-to-day location of the tropical cyclone Shana on the map showing the Philippine Area of Responsibility. Mark each location with a dot. Connect the dots to track the cyclone from June 30th to July 6th. At midnight on June 30th, the typhoon was at 8 degrees north and 133 degrees east. At 12 noon on June 30th, the typhoon is at 9.8 degrees north and 131 degrees east. July 1st, at 6 a.m., the location of the eye is at 11 degrees north and 128 degrees east. It is 12 degrees north and 126.5 degrees east at 6 p.m. on July 1st. July 2nd, at 6 a.m., the location of the eye is at 14 degrees north and 123 degrees east. At 6 p.m., July 2nd, it is at 14.5 degrees north and 121 degrees east. 6 a.m. on July 3rd, at 15.1 degrees north and 119.5 degrees east. At 6 p.m. on July 3rd, it's at 15.6 degrees north and 118.4 degrees east. On July 4th at 12 noon, the location of the eye is 17.1 degrees north and 117 degrees east. July 5th 12 midnight is at 17 degrees north and 116 degrees east. On July 5th, at 12 p.m., at 18.6 degrees north and 116.5 degrees east. 12 a.m. on July 6th, 19.5 degrees north and 117 degrees east. At 12 p.m. on July 6th, it is located at 20.5 degrees north and 117 degrees east. After plotting the coordinates, let us connect the dots. One, in what body of water did Tropical Cyclone Shana form? 2. What direction did Tropical Cyclone Shana take as it crossed the Philippines? 3. On what day did Tropical Cyclone Shana hit land? 4. Which provinces were hit directly by the eye of the tropical cyclone? 5. On what day did Tropical Cyclone Shana leave the Philippine Area of Responsibility? 6. Why is Mindanao not commonly hit by tropical cyclones? 7. What possible benefit do tropical cyclones bring? From the maps, you can see that tropical cyclones generally move in a northwest direction. The reason is because there are large-scale winds that push the tropical cyclones in that direction. This is similar to the way a whirlpool is carried along by a flowing stream. As you can observe, all tropical cyclones struck the northern part of the Philippines. Southern part of the Philippines is often untouched by tropical cyclones.